Hi, today we are going to see about sulfuric acid, which is called the king of chemicals, because whatever we do, whatever things are made, prepared, or whatever it is, all chemical industries are dependent on sulfuric acid. So it's a king of chemicals. It is widely used, highly corrosive, and we cannot be without it also. Okay, it's also called, another name is there, it's called oil of vitriol. These are the other names for sulfuric acid. The first thing, we can prepare sulfuric acid from concentrated nitric acid. Sulfur, when it reacts with concentrated nitric acid, gives you nitrogen dioxide plus water plus sulfuric acid. Alright, that is one way of preparing. However, the manufacture, now we move on to the manufacture of sulfuric acid. Manufacture is done by what is called contact process. This contact process is made of 4 steps. Okay, the first step, step 1, is formation of sulfur dioxide. This is step 1. How do we get sulfur dioxide? We can either get it from sulfur. Just burning sulfur and oxygen can give you sulfur dioxide. That is one way. The second method is, we also have iron pyrites. This is an ore of iron which is commonly found in abundance. So we can use this iron pyrites. It can be burnt in oxygen. That gives you iron 3 oxide plus sulfur dioxide. So here, so 8 here. So you have 6 plus 16. So this should be 11. Okay, so this is how sulfur dioxide is formed. Actually, this happens in this furnace where either sulfur is burnt in oxygen or iron pyrites are placed here and it is burnt in oxygen. So that is the first step. Next we move on to step 2. This step 2 is purification. See, both are gases. Sulfur dioxide is there, oxygen is also present, and it has to be purified. Now these gases, they have impurities like dust particles and others like arsenic is present. Moisture is there which has to be removed. So all these have to be removed. This happens in the purification. That is, this is the purification step. When this purification happens, after that, there is a box like Tyndall box, it is called, and this, when it passes through that, you would know, it would clearly indicate, okay, whether the sulfur dioxide that is formed is pure and the oxygen that goes in is also pure or not. Now if it is not pure, it will be sent back again to this to purify. The rest, the pure ones, will enter into this chamber. This is called the contact tower. And this contact tower is what comes under step 3, that is In fact, step 2. After purification comes this. Okay, so first point of this one, and this would be step 2 only. Second point. Okay, this is the catalytic process or catalytic oxidation. What happens here? This happens in the contact tower. This sulfur dioxide reacts with oxygen to give sulfur dioxide and a lot of heat. Okay, 2 and 2. This happens at a temperature of 450 to 500 degrees Celsius and pressure of 1 to 2 atmospheres, and the catalyst used is vanadium pentoxide. Okay, there is also a promoter, potassium oxide. Okay, now when we come to this contact tower, there are certain things that we need to know. It should be free from impurities. The first one should be free from impurities. This is what we did in the purification step. The first part we purified. Why? Because this vanadium pentoxide can be poisoned by impurities. That is why it should be free from impurities. The second point is platinum is not used because this can easily be poisoned, and besides it's also costly or expensive. So vanadium pentoxide is preferred because it is less easily poisoned and it is cheap. Platinum is not preferred because it's easily poisoned and it is expensive. The third point about this contact tower is reaction is exothermic, which means initial heating is enough. Heat is liberated within the system, and that heat is enough to bring the reaction to completion. So temperature is optimum 450 to 500 degrees Celsius. Pressure that is applied is 1 to 2 atmospheres, that is preferred. When it goes higher than this, it can damage the or it can decompose the catalyst. Catalyst is sensitive to that. Catalyst used is vanadium pentoxide and promoter used is potassium oxide. What is a promoter? Which increases the efficiency of the catalyst. Okay. So these are all the things that happen in the contact tower, and now we move on to step 3. Now when you come to step 3, actually we have got sulfur trioxide. The easiest way we would think is to just add water and we get sulfuric acid. But it is not directly absorbed in water. Why? Because this is hygroscopic liquid, has a great affinity for water. So what happens? And when it reacts with water, it is highly exothermic. So what would happen? There will be a lot of heat that is evolved. When there is a lot of heat that is coming, say you just have a bucket or a bowl of hot boiling water, you can have steam on top and you will not be able to go near that steam. You can't even keep your hand near that. So that is the amount of heat that is evolved, and as the heat is evolved, all the water vapor on the top also would evaporate. So it would not condense easily, but it will just form a dense fog of sulfuric acid, which will not condense easily. So now we have to go through two routes. So the third step is it will be absorbed in concentrated sulfuric acid. This is the third step. So this is concentrated to give you something called oleum or pyrosulfuric acid. Oleum or pyrosulfuric acid. This is formed. This is a higher form of the sulfuric acid that is formed. So we move on to step 4, which is dilution. Now we need to dilute this. So we take this oleum, dilute it with water to give you sulfuric acid, which is 98% concentrated. Okay, so this is how sulfuric acid is manufactured by contact process.